Welcome to the pre-calculus video for Unit 2B, Lesson 2, which is on adding and subtracting rational equations. So our first example is going to be for adding rational expressions that have common denominators. So step 1 says we're going to combine into one fraction. Step 2, we're going to factor out denominators if needed. And step 3, we're going to simplify, combine like terms, and we're going to make sure that we keep the denominator. Now, what we should know is that when we add two fractions that have the same denominator, you're going to end up with the two numerators being added and our denominator remaining the same. So here our denominator is x plus 6. Here our denominator is x plus 6. So in our answer, our denominator is going to be x plus 6. Our numerators, we are going to write them all out. X squared plus 8x plus 12. Now, we look at this and we say, okay, is there any factoring that needs to be done? My denominator looks fine. My numerator definitely can be factored. So we're going to factor this numerator into x plus 6 times x plus 2. My denominator remains x plus 6. We notice that we can do some cancellation. This will not always be the case, but in this example, there is cancellation. I'm going to cancel the x plus 6 with this x plus 6. Again, when we are canceling everything out of either the numerator or the denominator, I want to make sure that I put a 1 there. So that way I remember that there is still a 1 there. So this leaves me with x plus 2 divided by 1, or I could just write this as x plus 2. Now, if I still had anything remaining in my denominator, I would have to make sure that I identify any constraints by setting the denominator equal to 0, the same way I did for multiplication and division. So in example 2, we're going to be subtracting rational expressions with common denominators. So we're going to follow similar steps. 1, we're going to factor out any denominators if we need to. We're going to put parentheses around the polynomial in the numerator, distribute our subtraction symbol, and then simplify. So I'm going to first notice that my denominators are the same, x squared plus 7x plus 12, x squared plus 7x plus 12, which means that in my answer, I'm going to have x squared plus 7x plus 12. For the numerator, I'm going to have to write this as one long division problem. So I have x squared minus 2x plus 3 minus, and I want to use parentheses here because I want to make sure that I understand that I am not just subtracting the first term. I'm subtracting the entire expression from the numerator of the second fraction. So x squared minus 4x minus 5. Well, in order to simplify this, I'm going to have to distribute this negative sign. So let me rewrite this fraction, x squared plus 7x plus 12 as my denominator, 12. My numerator, I still have x squared minus 2x plus 3. Now I'm going to do my distribution. Negative x squared, because I'm just taking this and distributing to all three of these. Positive 4x, positive 5. I'm going to combine my like terms. So I notice that I have x squared and minus x squared, which those will create a 0 pair. I have negative 2x and positive 4x, meaning that in my numerator I still have a 2x. Here I have positive 3 and positive 5, which gives me plus 8. My denominator, Still x squared plus 7x plus 12. Now, I'm going to do any simplification through factoring that I can. I'm going to factor a 2 out of my numerator, just in case, leaving me with 2 times x plus 4. I'm going to factor my denominator, which will become x plus 4 times x plus 3. Notice again that I can cancel factors of x plus 4 from both the numerator and denominator, leaving me with 2 divided by x plus 3. Now, before I finish this problem off, I need to make sure that I've taken into account my constraints. If my answer is 2 divided by x plus 3, then I know x cannot equal negative 3. And I need to make sure that I'm noting that as my solution. For example 3, we're going to be dealing with adding and subtracting rational expressions that have unlike denominators. Our first step is going to be to factor, if we need to, our denominators, because we want to make sure that we have a common denominator, and in these examples we won't. So we're going to have to do some factoring to make sure that we have an understanding of what it is that we need to multiply by to make that denominator a common denominator. We are going to multiply the numerator by the same factor as the denominator. And we're going to follow with the steps for adding and subtracting rational expressions with like denominators to finish off the problem. So when I look at this first example here, I notice my denominators are x minus 3 and x plus 5. Now, if I were doing a problem with just numbers, so say for instance, I'm not rewriting this, but I'm just going to do a separate example here. If I were doing 1/3 plus 2/5, then I would say I cannot add these unless the denominator is the same. So I would say what I'm going to do is I'm going to multiply both of them, so that way my denominators are the same, and I would say, okay, this is 3, this is 5. 3 times 5 is 15, and 15 would be the denominator of both my fractions. In this case, I still have x minus 3 and x plus 5. I'm still going to have to multiply them together in order to get my denominator. So I'm going to say, for my x minus 3, I need to multiply by x plus 5. So I'm multiplying my two denominators together. But since I had to multiply by x plus 5 in the denominator, I also have to multiply by x plus 5 in the numerator. Plus, for the second one, since I already have my x plus 5, here let me write it in the same order, I'm going to have to multiply this time by x minus 3, which means I'm going to have 2 times x minus 3. At this point, I'm going to combine the same way that I did on the previous page by just adding my two numerators together. And I have x plus 5 plus, and I'm going to distribute this 2x minus 6. So this is my numerator, and I'm going to, of course, give it the denominator of x minus 3 times x plus 5. I'm going to combine all of these terms. X plus 2x gives me 3x. 5 minus 6 is minus 1. For this denominator, I commonly want to multiply these together. So I get x squared plus 2x minus 15. And I remember that I still don't want my denominator to equal 0, so I'm going to say that x cannot equal positive 3 or negative 5. Now, the subtraction follows in a very similar fashion. Again, I'm going to start by realizing that my denominator has to be the product of x minus 2 and x plus 1. So I will get 3 times x plus 1 divided by x minus 2 times x plus 1 minus 2 times x minus 2 divided by x minus 2 times x plus 1. I'm going to distribute and subtract 3x plus 3 minus 2x plus 4. Understand, I'm distributing this 2, but I'm also distributing this minus sign. So you can almost think about it like multiplying negative 2 times x minus 2. And my denominator is x minus 2 times x plus 1, giving me 3x minus 2x is 1x, 3 plus 4 is 7, over, and I'm going to multiply these out, which gives me x squared minus x minus 2, with constraints that x cannot be equal to positive 2 or negative 1. Now, these were problems where both of the denominators were very different. When we look at our next example, they appear very different, but appearances can be deceiving. We want to make sure that we're factoring out our denominators first. So when I rewrite this, I'm going to write x times x minus 1. But I know that x squared minus 25 is x minus 5 times x plus 5. So now what I'm noticing is that my two denominators have a common expression. Here is an x minus 5, here is an x minus 5. Now, what that means for me is that I won't have to multiply my first fraction at all because it already has the x minus 5. But this denominator needs to be multiplied by x plus 5. So I'm going to rewrite my first fraction, x times x minus 1, divided by x minus 5 times x plus 5. And I'm going to subtract x minus 3 times x plus 5 divided by x minus 5 times x plus 5. So you'll notice I'm multiplying my second fraction by x plus 5 so that way those denominators match. So for this problem, because there's a lot going on in both the numerator and the denominator, I'm going to distribute in my numerators as I'm going through the process of doing the subtraction. If you need to distribute first and then subtract, that's what you should do. So I have x squared minus x. That comes from the numerator, my first fraction. Then I'm going to multiply these together, which is, and distribute the negative sign, which is minus x squared minus 2x plus 15. And this is all divided by x minus 5 times x plus 5. Now, you'll notice I have not multiplied my denominator together yet because I want to see if there might be a factor that cancels. In my numerator, I see I have an x squared and a minus x squared, which create a zero pair. So combining my other like terms, I have negative 3x plus 15 divided by x minus 5, x plus 5. I see that both the terms in my numerator I could divide by negative 3. So negative 3, I factor it out and it leaves me with x minus 5. and my denominator of x minus 5, x plus 5, now I see that I can do some cancellation. There's an x minus 5 in the numerator and an x minus 5 in the denominator, leaving me with negative 3 over x plus 5, and I know that x cannot equal negative 5, or that will make my denominator equal 0. Our last example, we're going to run through the very same steps. We're going to do some factorization, see what it has in common, see what is different. So I'm going to say that this is 7 divided by 3x times x minus 2 plus x squared over x minus 2, x minus 2. Now, I notice that these have this x minus 2 in common, but both of them are still going to have to be multiplied. So my first one, I'm going to multiply by this x minus 2 here. So 7 times x minus 2 over 3x times x minus 2 times x minus 2 plus x squared, and this second fraction, because it doesn't have this 3x, I'm going to have to multiply by that 3x. So x squared times 3x, x minus 2, x minus 2, 3x. Now, you're going to be tempted to try and cancel out these 3x's, but remember, that's the point. We're multiplying both the numerator and denominator by the same thing, so do not try to cancel yet. I'm going to combine these together. So you're going to see me do the distributive property, so that way I can kind of like piece things together. I have 7x minus 14 plus 3x squared. And that is all divided by 3x times x minus 2 times x minus 2, which I don't... Nope, sorry, that's 3x cubed, not 3x squared. Wow. 3x cubed. Because it was x squared times 3x. All right, so I'm not sure that this one's going to factor out. This might be something that I need to check on at another time. So I end up with 3x cubed, because I'm going to write it in the appropriate order, plus 7x minus 14. And if I want to multiply out this denominator, I can. For this problem, I'm not going to. I'm going to say that it's 3x times x minus 2, the quantity squared, meaning x cannot equal 0 or positive 2, because 0 would make this equal 0, positive 2 would make this expression equal 0. If you have any additional questions, make sure that you jot them down so that way you can ask them the next time I see you in class.